in our second session, we'll be discussing about alkanes, alkenes and alkynes in details. Before that, let us once again recapitulate about what is this alkene, alkane and alkyne. As told in the previous classes, saturated and unsaturated. Saturated means single bond and unsaturated means double and triple bond. And this double and triple bond, they are further classified into their own specific names, such as alkane means alkane, it has the suffix a and e, that is alkane. And alkene, alkyne. Alkane means single bond, alkene E means double bond, and alkyne means triple bond. Just remember the last three letters. That means if you see it A and E, it will be single bond, E and E will be double bond, and Y and E will be triple bond. Now let us study about all these three in details along with their members. First one, alkane, which has the suffix A and E. Now, alkane means single bond. Alkane has its own general formula, which is CnH2n. C represent carbon, H represent hydrogen, and N represent the number of carbon atoms. CnH2n plus 2 is the general formula. We can write here general formula of alkane. Depending upon this formula, we can know the members of alkanes. Before we know the members of alkane, let us see if the carbon, as I said, N is the number of carbon atoms. If the carbon atom is 1, let me write here so that I don't need to rub it again. If N is 1, the prefix means those words which are added ahead, which are added in the beginning. So if N is equal to 1, the prefix will be meth, M-E-T-H. If N is equal to 2, it will be it. N is equal to 3 will be prop. N is equal to 4 will be but. N is equal to 5 will be pent. N is equal to 6 will be hex. N is equal to 7 is hept. N is equal to 8 is oct. N is equal to 9 is non. And N is equal to 10 is dec. But according to your textbook, we will be studying only about the 6 numbers. So remember this. If you remember this, you will be easily able to do the naming. If N is equal to 1, the prefix will be meth, meth. N is equal to 2, it will be eth. N is equal to 3 will be prop, prop. N is equal to 4 will be but, but. It is not but, it will be but, but. N is equal to 5 will be pent, and N is equal to 6 will be hex. Now let us see the first member of alkane. For alkane, N can be any number starting from 1, 1, 2, 3 and so on. Now let us see for N is equal to 1. N means the number of carbon atoms. We are taking the number of carbon atoms as 1. So in place of N everywhere, we'll be putting 1. We'll be substituting 1. So C1H. In place of N, we'll be putting 1 plus 2. Upon simplification, we'll get this as C1H. 2 into 1 is 2 plus 2. Generally, when we see 1 subscript, we generally ignore it, we don't write. So even if we don't write 1, Note that there is a subscript which is 1. So C1H2 plus 2, 4. CH4. For n is equal to 1, we got CH4. Now what is the name of this CH4? As we can see from that line, that if n is equal to 1, what will be the prefix? It will be mid. And for which category are we doing? We are doing for alkane. What is the suffix here? What is the three ending letters A and E? The first prefix will be taken from the number of atoms, and the ending letter will be the letter for which category we are doing the calculation. So we are doing for alkane, so the third last three letters will be A and E. That means it is the first three prefix will be from the number of atoms, that is mid, and the third and the last three letters will be from the category. That means we are doing for alkane, so A and E will come from the category. That means METH will come from the prefix and A and E will come from the alkane. So the name of this compound is methane. Let us now see the dot structure of methane, CH4. We know that carbon has 4 valence electrons. That means 1, 2, 3, 4. And since the formula is CH4, we will have 4 hydrogens. So one hydrogen here will place in such a way that we can easily draw the bonding. Hydrogen and this hydrogen. Since we are putting the dots, this is known as a Lewis dot structure. Now, hydrogen, we know that in order to attain stability, it needs 2 electrons, and carbon, in order to attain stability, it needs 8 electrons. We already have 4 electrons for carbon, it needs 4 more electrons. For hydrogen, we need 1 more electrons because it has already 1 electron in it. So, as we have already discussed that carbon forms only covalent bond, that means sharing of electrons. So, this hydrogen, carbon is known to be very friendly. So, this carbon agrees to give 1 electron to the hydrogen to attain stability. It agrees to give 1 electrons to all the hydrogens so that they can attain stability. So this hydrogen, carbon shares 1 electron to this hydrogen, it becomes 2, attains stability. This carbon also shares its 1 electron and this hydrogen attains stability. Same in these two cases also. Carbon share its 2 electrons and make all the hydrogens stable. Now, it is the responsibility of all these hydrogen to make carbon stable because carbon has made them all stable by sharing its electron. So now what hydrogen will do is, hydrogen will also share its 1 electrons to the carbon so that it becomes stable. Carbon already has 4 electrons, it needs 4 more electrons. So all this hydrogen will share its 1 electron each. So upon sharing of electrons, now when we count the number of electrons for carbon, 1, 2, 3, 4, 5, 6, 7, 8. So carbon, it has attained stability as well as hydrogen has attained stability. And as we discussed that 1 pair of electron, that means 2 electrons will give a single bond. Now in all this case, you see that there are only 1 pair of electrons. So that means this is a Lewis dot structure. If we are asked to draw a covalent structure for methane, it will be in this form: C single bond H. Because from this Lewis dot structure, you can see that only 1 pair of electron has been shared. That means it will have the single bond. Remember that methane is the simplest alkane. Now let us see for ethane. The next member, for n is equal to 1, we got CH4. Now let us see for n is equal to 2. For n is equal to 2, we will be putting N is equal to 2 in this general formula. So C2H2 into 2 plus 2. So upon calculation we'll get C2H4 plus 2. 2 to the 4 plus 2. So we will get C2H6. Now for one carbon, what was the prefix? Met. For two carbons, what will be the prefix? It. It. And since we are doing for alkane, what will be the suffix? A and E. So the name of this compound is ethane. For methane, for CH4 it was methane. Met from the number of carbon, that is 1, A and E from the category alkane. It from N is equal to 2, that means we are taking carbon 2, and A and E from the category of alkane. And Lewis dot structure will be the same as methane, and if we are asked to draw the covalent structure, it will be, since there are two carbons, and see we are doing for alkane, that means there is no chances of having a double bond, all will be single bond. Two carbons are attached, now 6 hydrogen. If we try to maintain the tetravalency, automatically we'll get 6 hydrogen. Now you see here, one bond is there, so carbon has one bond. It needs how many bonds to be stable to attain tetravalency? 3 more bonds. Here also it needs 3 more bonds to be stable to attain tetravalency. And know that if there are no atoms present here, always there will be hydrogen. Now you count the number of hydrogens: 1, 2, 3, 4, 5, 6. 6 hydrogen, 2 carbon. So this is the covalent structure of ethane. Similarly, you can also do it for all the hexane and everything. Now let's quickly see for hexane. If N is equal to 6, C6H2 into 6 plus 2. Putting the 6 in the general formula, we will get C6H2 6h12 plus 2 will be 14. 6 carbons. So even if you are not sure, you can directly draw the 6 carbon with a single bond, because we are talking about alkane, that means it will have a single bond. And 14 hydrogen, you cannot directly draw the 14 hydrogen blindly. You first have to see the tetravalency. If you maintain the tetravalency, automatically you will get 14 hydrogens. So here it has only one bond, that means it needs 3 bonds. Here 2 bonds. In order to make 4, we need 2 bonds. Here 2 bonds, we need 2 more bonds. Bonds means they are made up of hydrogens only. So here again they need carbon has tetravalency, so it needs 4 bonds by any means. So here carbon has 2 bonds, it needs 2 more bonds to maintain tetravalency. The same thing applies here, and here since it has only 1 bond, we need 3 more bonds to be stable or to attain tetravalency. Now you check the number of hydrogens. It will come out to be 14. Altogether, the formula is C6H14. Now, how do we name it? Since we are taking N is equal to 6. N is equal to 6 means what? It is hex. And since we are doing for alkane, the suffix will be A and E. So, the name is hexane. So, by now, I'm sure you will be a little clear about how the members of alkane can be written down. Now let us see for alkene. The difference is only in the last three letters, E and E. Alkene. Alkene means, as I said, it will have a double bond. This category is similar for all alkene, alkane and alkyne. The only difference is in the general formula. General formula of alkene is CnH2n. C is for carbon, H is for hydrogen, N is for the number of carbons. So if we take, and remember one important point for alkane, A and E, N can be any number from 1, 2, 3 and so on. But for alkene, E, and for alkyne, N can be any number but from 2, 3, 4 and so on, not from 1. Remember this point. For alkane, the number will start from 1. For alkene and alkyne, the numbers will start from 2. Because why 2? Why not 1? Because for alkene and alkyne, alkene means double bond, alkyne means triple bond. And carbon cannot form a bond with hydrogen. We are only talking about hydrocarbons as of now. So here, alkene, we need 2 carbons in order to attach the bond. So if we take N is equal to 1, carbon will be 1. So carbon, it will not have any atoms to form a bond. That is why for alkenes and alkynes, N starts from 2 so that it can have 2 carbons to form the double and triple bond. Now let us see the members of alkene. For N is equal to 2, C2H 2 into 2. So it comes to be C2H4. Now alkene C2H4. How can we name it? For N is equal to 2, what is the prefix? ETH is the prefix. ETH. And for which category are we doing? We are doing for alkene. ALKENE. We are doing for E and E. So it will be E and E. So it will be, the name will be ethene. Now we know that alkene means we are talking about double bond. So logically you will know that between 2 carbon atoms there will be a double bond. Because we are talking about alkene. If we were talking about alkanes, it will have a single bond, but for alkene we have double bond. Now we have to maintain the tetravalency. For carbon, it has already 2 bonds. So how many bonds does it need more to attain 4 tetravalency? It needs 2 more. Here also, how many does it need? It already has 2 bonds. This bond is shared by this carbon as well as this carbon. It already has 2 bonds, so now it needs 2 more bonds. These bonds means they are hydrogen. Now you see the formula and see the structure. Carbon is 2 carbon. 2 carbon, hydrogen how many? Hydrogen 4. Alkene means it will obviously have a double bond. Now let us quickly see for hexene. When N is equal to 6, N is equal to 6, that means what will be the name? N is equal to 6 means it is hex. And for which category are we doing? We are doing for alkene. So the suffix will be E. So it is hexene. Now let us try to put the formula. N is equal to 6. So Cn will be C6. H2N will be 2 into 6. So we get C6H12. Now let us see how can we draw the structure of C6H12. C6, how many carbons are there? 6 carbons. So 1, 2, 3, 4, 5, 6. Initially just join it by a single bond. We are talking about hexene. That means in this single bond, at least there will be a presence of double bond somewhere. All will be not double bond. There will be a mixture of single as well as double bond. Even if one double bond is present, that means this entirely belongs to alkenes. If directly only 3 bonds are available at one point, that means this belongs to the alkyne category. But now we are talking about alkene. So let's say we are putting here double bond. Now let us try to maintain the tetravalency. Here 1 bond is present. We need 4 bonds altogether. So here Already one bond is there, so we'll put 3 bonds. Here already 2 bonds, that means we can put 2 bonds to make it 4. 1, 2, 3, 4. Here also for this carbon, it is sharing 2 bonds. So we can put 2 more bonds. Here you check. How many bonds is this carbon sharing? This carbon is sharing 1, 2, 3 bonds. This carbon has already 3 bonds. In order to maintain tetravalency, how many bonds does it need now? 1 bond. You can either place here or here, it's up to you. Similarly here, this carbon also has 3 bonds. It needs only 1 bond to attain tetravalency. This carbon has 1 bond. How many bonds does it need to attain tetravalency? It needs 3 more bonds. All these bonds represent hydrogen. Even if you don't write any atoms above these bonds, it will be assumed that hydrogens are present. So when you count this, carbon are 6 and hydrogen, how many hydrogens will be there? 12 hydrogens. So this is how you will draw the covalent structure. I'm sure by now you will know how the naming is done. Now let us take just one example of alkyne. Y and E. This is triple bond and the general formula is CnH 2n minus 2. As I said, the number of atoms will start from 2 onwards. So if we take n is equal to 2 and put it in the formula, C2H 2 into 2 minus 2. So we will get C2H, 2 2s are 4 minus 2. So ultimately we will get C2H2. Now regarding the naming we have to follow the same format as for alkene and alkyne. So since n is equal to 2, what will be the prefix? What will be the first word? ETH. Since we are doing for alkyne, what will be the suffix? Y and E. So the name will be ethyne. Now when we see the structure, already 2 hydrogens are present and we know that we are doing for ethyne, which means we are doing for the alkyne category, Y and E, and we know that Y and E means triple bond. So we can directly put triple bond between these 2 hydrogen atoms. Now let us see how can we maintain the tetravalency. This carbon already has 4 bonds. So how many bonds does it need to become 4? Only 1. This carbon also has 4 bonds already. So it needs only 1. Now you check the formula C2, H2. How many H? 2H. Now let us quickly do for n is equal to 6. When n is equal to 6, so C6H2 into 6 minus 2. So we will get here C6H12 minus 2. So here 12 minus 2 we will ultimately get C6H10. So C6 means there are 6 carbon. 1, 2, 3, 4, 5, 6. Since we are talking about alkyne triple bond, at least 1 bond will be triple bond. We can put anywhere, at least 1 triple bond. Since there is at least 1 triple bond, it belongs to alkyne category. Now let us maintain the tetravalency, which is 1 bond, so it needs 3 more bonds to attain tetravalency. 2 bonds, so 2 more bonds. Here you see 1, 2, 3, 4. Already the tetravalency has been maintained for this because already has 4 bonds. So we will not make any changes here. Even for this carbon you see 1, 2, 3, 4. Already 4 are there. Already tetravalency has been maintained for these 2 carbons, so we will not make any changes. So for this carbon we have 1, 2. We have only 2 bonds, so we need 2 more bonds to maintain the tetravalency. And for this, it has only 1 bond, so we need 3 hydrogens. The hydrogens can be placed either in a straight manner or any position, any equatorial positions also. So please don't get confused. So this, when you count the numbers of carbon and hydrogen, you will find that 6 carbons are present and 10 hydrogens are present. So when you are drawing the structure, Carbon, if it is mentioned 3, you will put 3 carbons. And hydrogens, when you maintain the tetravalency, you will find out that the hydrogen numbers that you find here will be equivalent to the numbers of hydrogen present in your formula. And how do we name this compound? We know that for n is equal to 6, we have the prefix as hex. And what is the suffix? That means what is the category we are doing for? We are doing for YNE, alkyne. So the suffix will be YNE. So the name of this very compound will be hexane. So this was all about the 3 categories, which are alkane, alkene and alkynes. That means single bond, double bond and triple bond. By now, I'm sure it will be quite clear, but in order to name them, you first have to keep in mind what is the name given for 1, 2, 3, 4 and 5 carbon atoms. If you are not familiar with this, you will not be able to name them.